Okay. So hold them for a while until I be patient.
Yes.
Okay, great. Uh, okay, so I'm going to continue with the last part for chapter 4. So chapter 4 was mainly on the time value of money. So what we were talking before about the time value of money is looking into the value of same amount of money, which is actually going to be applicable for anything in the future. So we have, I've already explained the concept to you. What I'm going to introduce you today is the application of future and the present value. So looking into the simple definition, which you can see here, we have present value is the value today of a future cash flow. So basically you're going to be calculating how much is the value of something that is going to be, for example, given to you in the future. So this is the present value. You want to know the value of it today. Where future value is amount to which an investment will grow after earning interest. So basically, this one actually represents, similarly, if I want to give you an example, it's like when you are, let's say, for example, saving money or investing your money in the bank, and the bank is giving you an amount of interest. So how much actually you're going to be having in the future. So you are going to be increasing the value of your money in the future, and then you want to know how much is that value is going to be. So whatever that you have learned actually so far is going to be, we are going to put it into calculation today. Okay, the calculations are actually quite very straightforward and simple. The only thing about this part is that because you actually have to do calculations several for the several different types, for the several types, it would be quite sometimes difficult for everybody to uh, somehow memorize actually the formulas. So the best way that you can still do the calculation without needing without needing actually to memorize the formula is what we are using, and we call it as notation. So notation and cash flow diagram and table. So notation is something that it actually represents the same or the similar concept as a formula, only that you can write a notation according to the information that is given in the questions, for example, or the situation or the scenario that you have. And it also allows you to simplify the calculation, and the answer is actually could be more accurate rather than using the formula sometimes. Okay, so the notations that actually we are using for the notation used in formula for compound interest calculation. So you are already familiar with the I, which is the interest. You're already familiar with N, is number of compounding on the interest period or year. So this is our, when we are talking about the duration or year. This is something that you're also familiar with before this. Then we have the P, which represents the present sum. F represents the future sum, and A represents annually. So we have this tree that you should be able to do the calculation for each one of this tree. But the only thing is that all of them, the way actually the calculation is happening for the present value or the future value, or even for A, which is annually, all the calculation following exactly a same method. So if you just learn one time how to do the calculation for one of them, it's only actually changing the value, except that. Okay, so for the present sum of money is equivalent value of one or more cash flow at a reference point in time, which is the present. So we are talking about, when we are talking about the present sum, is either that you are looking for the present sum. If the present sum is actually something that you are going to be calculating, so in that case, usually the future sum should be given. Keep in mind that always one of these items actually should be always given to you. Either you should have a present sum, and then based on the present sum you want to calculate the future, or the future is already given to you, and according to the future you want to calculate the present sum. Okay, so if you look at this slide here, this is notation for calculating a present value. So pay very good attention when I want now to explain to you the present value. And trust me, if you only learn one of this concept, for example, this is only for the present value. Every other one is exactly the same. It's just that the formula, the notations, everything is the same. It's just that they're going to change places. So the formula, the way actually you're going to go through with the calculation is exactly the same. Okay. So if you look, the first thing that you see here, this is the formula that we have. So we have the P, which is the present, equal. So this is the future sum, 1 divided by 1 plus I, which is the interest. And then we have it in the power of N, which is the duration. So this is the formula that you can memorize it and then later on use it if you are asked to calculate, for example, the present value. When we are requesting, or when actually present value is the value that is missing, in this case, it definitely you are going to have the future value. So if I want to put it into an example, for example, if I tell you, if you are going to have, let's say, 1,000 ringgit after 1 year, so you have something that is related with the future. So you want to know how much is the value of same amount today. So you are basically you are going to find the present value. Okay, so this, what we have here is the using the formula. You can use this formula, and then based on the information that is given to you, you can put it into calculations and you can give the answer. You can come up with the answer. Why I say memorizing? Because this kind of formula, of course, is not going to be given to you in the exam. And then because there are we have like multiple formulas like this, and all of them are the same. So actually the percentage of you making a mistake or error between these formulas is actually very high. So I do advise you to, most of the times, you can always use the functional notation. Functional notation, what it is? Functional notation, remember that it is not a formula. Many students, they make mistake that they think this is a formula and they can either use this or this. It is true that you can use one of these two, with the difference that the first one that is above, it's a formula so that you can place your number and get the answer, where the second one, where you see here under the functional notation, this is not a formula. It means that you're not going to be placing, for example, number or values for each one of these items, and then it's going to be giving you an answer. So that's a very wrong concept. So how you can read a functional notation, for example, for this one, we have P, which is the present value. So this is something that is missing, and you want to be calculating the present value based on a future sum that is already given to you. So you can calculate the present value based on a future sum that is given to you. What you see here, we have P/F. This is not P divided by F. Do not get confused that this is P divided by F. No. In a notation, we read this as a P/F. And then we have I, and then we have N. So I is the interest that is given to you. N is the duration that is also given to you. So the P/F means present value of a future sum. So this is how you should be reading it. So we are looking for the present sum. The future value is given to you. So you want to know how much is the present value of a future sum at the interest rate of I in the duration of n years. So this is how you're going to be reading the notation. So if we want to put this into numbers, for example, this is just an example. If the future sum is given to you 5,000 and the interest is 6% and the duration is 10 years, so this is how you will be writing the notation. So 5,000 is the future value. P/F means that you want to know what is the present value of a future sum. So always remember, we have here P/F. The first one is always the one that is missing, and the value after the slash is the one that is already existing. It means that the one that you have it. So in this case, P/F means you do not have P, you are looking for P, and F is the one that you have. And this F and this one is actually the same thing. The only thing that this is not a formula. If I want to explain a functional notation to you in a very easy or simple way, the best definition, it's not actually a definition, it's something that I come up by myself, but the best way that I can say to you what is functional notation, simply it works to me like a GPS. Like how you want to go, let's say you are driving and then you want to go to a certain location. The easiest thing that you would do is just that you're going to be using your phone, and then you're going to, let's say, open the GPS, you're going to open the Google Map, and then you're just going to enter your location and the destination, and the Google Map is just going to guide you through to make sure that you will reach the exact location that you have. So it's just showing you the way to reach your destination. Functional notation is exactly the same thing. It is not a formula. It's actually giving us direction how to reach to a number. So the only things that here could be calculated, that is 5,000. For example, this is the future value, the 5,000 times whatever that we have here. But keep in mind, P/F, 6%, 10 years, it's actually the direction how to get a value for it. You're not going to be, for example, here's, do not get confused like 6% times, for example, 10. No, it's a wrong concept. Or divide is also a wrong concept. Okay, so interpretation of P/F/N is actually reading the same thing. A present sum, which is P, given a future sum, which is F, and interest period, which is the duration, add an interest rate, which is I, for the interest period. Okay. So what you saw here, it is for the present value. The next one is actually going to be for the future value. As I told you, if you only learn one of these formulas, every other formula is actually the same, the very similar concept with the first one. So looking for the future value, it means that the future value is missing, and what is being given to you is definitely going to be the present value. So similarly, if you want to put it in terms of the formula, so we have F, which is missing, P, 1 plus I, which is the interest rate, in power of N, which is the duration. So if we want to put this into notation, which would be definitely more simpler in order to get the answer, so we can write it as F equal, because you're looking for F. So P, the present value, is the one that is given to you. And for writing the notation, I told you the first one is the one that you are looking for, and the second one is the one that is already given to you. So for example, for the future value, you want to calculate the future value based on a present sum that you already have. I, which is the interest, and N, which is the duration, is already given to you. Okay. Another thing that you want to keep in mind is that all these two so far, these two that I have already introduced to you, present value and the future value, both of them are based on single payment. Single payment means that only one-time payment is required. For example, if we are talking about, let's say you want, for example, if you get a loan today, and then there's going to be an interest of, let's say, 6%. If I want to put this, for example, into an example, if the interest is 6% and the duration is 10 years, and let's say, for example, you got a loan, you are only going to be returning the money one time at the end of the 10 years. So there's only one time payment. This is for single payment. If there are going to be multiple payments, so the scenario is actually a different scenario. So for now, we are only looking at a single payment. Either you're going to be receiving money one time today, or you're going to be paying off the money one time in the future. So far, these two methods are only for the single payment. Remember that. Okay. So now, putting these two beside each other in order to get the comparison between the present and the future value. So using the standard notation, we can find a present amount, which is P, can grow into a future amount, F, in N, which is a duration at the interest rate of I. Okay, so here we are looking for F. And in the second one, we are going actually to look for the present value, which is P. So if I want to make it more simpler for you, here is finding F when given P. You have been given you have the present value, you know what is the value of it today, and you want to calculate how much the same value is going to be in the future. Which, for the second one, finding P when given F. You know what or how much is the value in the future. It's already been given to you. It's already clear to you. But you do not know how much is it going to worth right now today. So I hope that now is actually making more sense to you. After this, we will do a calculation to clear everything for you. But what I want you to understand very clearly is that we started chapter 4 with the concept of time value of money. Time value of money, it's the easiest or the simple explanation which I can give for the time value of money is that as time passes, the value of money is also changing. So the example that I always used to give you is that if you have 1,000 ringgit today, right now with you, whatever that you can do today with 1,000, right now, today, is going to be different than what you can do with 1,000 ringgit next year. Because next year, you most probably, you won't be able to perform the same thing. For example, if you're purchasing an item, you cannot purchase the same item exactly with the same amount of money. Definitely, you are actually required to add some additional. So that additional is always going to be similarly with the interest rate that we have. So now I'm actually trying to combine everything in the beginning of chapter 4 until here, so that actually it's going to make sense for you. So the interest rate is actually going to allow you to keep the value of the money, especially when we are talking about the future. Okay. So what you see here is something that you are familiar with it already and you know how to calculate it before. So this one is for the single payment formula. What we have is like you want to know the what you have is actually the P. You have the present. So you have the first payment, for example, the first year. So this is 1 year, 2 year, 3 year, the number of the year that we have. This is, if you still remember, this was based on the manual calculation. The amount that we have is P, so it could be any number. So if you still remember, this could be, this actually, the amount that where you start, we call it as the principal, if you still remember, hopefully. But there is another thing that I don't want you to get confused. There is a, not actually a difference, but principal is one thing, but also we initiated this also as P, but the P that you see here is a present sum of money. Why here is present sum of money, even though the calculation is exactly the same thing, is just that because here we are talking about the present and the future value at the same time. Unless the principal, but it acts as the same thing. So what you see here is the principal or the present sum, whatever that you start with today. So this is actually the amount of money that you might have right now today. The second column is actually the interest. So for example, 5% of whatever that you have today. So at the end of the year is actually the total amount, the total principal that you have, plus the interest. So if you still, I hope that you can still remember this, because this is something that we have covered in the first and second part of chapter 4. So the important was that the second year principal is going to be the first year payment. And we call that as, we called that, I forgot the name. So we had two different type of interest. The single interest was only that your principal never changed. Where the compound interest, it was exactly the one that now you can see right in front of you. So this is considered as a compound interest, that your principal keep on increasing. If I want to compare it with a single interest, whatever amount that you see here, for example, if this is now P, the second year, third year, fourth year still is going to maintain as P. But what you see here is actually the P plus the interest, which is considered as a compound interest. And in a real life, in most times, for example, we are actually going to be using compound interest. And these calculations are all based on compound interest. So this is something that you're already familiar with. This is the manual calculation. It is still going to give you the right answer. The only difficulty in the manual calculation is that, let's say, if the duration is going to be very long, then of course the calculation is going to be very tedious. It's going to take a very long time for you to do the calculation. If I give you the duration, for example, for 20 years, so basically you have to be repeating this for 20 times, and then the error that it might happen in the calculations also, of course, is very high. So this is the manual calculation, where we can always, of course, use the formula in order to get the answer faster. Okay, so this is the example that we have for the manual calculation. Suppose that you borrow 8,000 now, promising to repay the loan principal plus accumulated interest in 4 years. So n equal 4, this is our duration, at I, which is the 10% per year. How much would you repay at the end of 4 years? So you can see that the question is given you the principal, which is 8,000, the duration, which is 4 years, and the I equal 10, which is the interest is 10%. And the question, and okay, wait, hold on, because who said, somebody sent me a message that they cannot enter. Okay, give me a few minutes. Okay, so let's continue because some of the students, they couldn't join. I've already allowed. Okay. So the first thing you want to do when a question is given to you, you want to make sure that you summarize the question easily for yourself. So here we have P equal 8,000. We have N equal 4 years, I equal 10%. What is very important here is that how much would you repay at the end of 4 years? So we are still talking about one single payment. Only one time you're required to be paying the money at the end of the 4 year. Okay, so based on the manual calculation, so we have the first year, the principal is 8,000. The interest is 10%, so means 10% of 8,000 is going to be equal 800. So at the end of the first year, the value is going to be 8,000 plus 800, which is going to be 8,800. So 8,800 is going to be the new principal for the second year. So again, 10% of the 8,800 is going to be 880. So 880 plus the initial 8,800 is going to end up with 9,680. So now 9,680 is again the new principal for the following third year. So the same thing is going to happen for the fourth year, and then the total is going to be 11,713. So at the end of 4 years, you're going to be repaying 11,713. This is sorry. Okay. At the end of 4 years, you're going to be repaying 11,713. While you have borrowed 8,000 for the duration of 4 years at the interest rate of 10%. So this is the manual calculation. You have learned this previously. This is, we call it as the for the interest that we had. So this is not something new, but it's manual calculation. So now what I want, to tell, and now what I want actually to let you try is that if we want to not to proceed with a manual calculation, so now we just want to use the formula, but now the important is I want to use both the formula and the notation at the same time to make sure that you're actually going to get exactly the same answer. Okay, so here we have a simple example. If you had 2,000 now and invested at 10%, how much would it be worth in 8 years? So exactly, if I want to go back, you can use the same method. You can use the same method like this. The only difference that this time around you have 2,000, it is 10%. It's still going to be the same percentage. And here you have done the calculation for 4 years. It's just that you want, instead of 8,000, use 2,000, and you want to increase this until 8 years. And you would still, at the end of the day, get an answer if you want to do it manually. However, definitely it's going to take a very long time to do the calculation. So what we can do, we can simply, let me go in front. So we can simply use the formula. The first method, this is the same thing. If you had 2,000 now and invested at 10%, how much would it worth in 8 years? So this is the simple formula that that I introduced it to you in the beginning. So if you are somebody who is very good with memorizing formulas, so you can proceed with this. So this is the first method. You have the present value, and you want to know this value, the 2000, how much is it going to be after 8 years with 10% interest. So you're looking for the future value. So F equal, you have the present value, 1 plus I in the power of n. So P is equal 2000. We have the interest at 10% and the duration is 8 years. So at the end of the 8 years, the future value is actually going to be 4,287. So this is if we are using the formula. The second method that I told you, it's actually using the notation. So the thing about the notation is that you have to write the notation by yourself, but it's actually very simple. Here you can understand from the question that the future is missing. So what you are looking for is future. So F equal, that's the first thing. What is given to you, you have the present. So you just write P. And for writing the notation, again and again, I told you, if you are confusing which should be slash which one, remember that the first one is the same one here, means that the first one is always the one that you are looking for, and the second one is the one that it's been given to you. So in this scenario, we do not know what is the future value, where we know the present value is 2000. So F slash P, the interest is 10% and the duration is 8 years. Okay, so this is until here you have written the notation. So how you can find a value for this, because I told you you are not going to be times in this number. So P is 2000, F slash P, you just convert it here, I is a 10% and N is 8 years. How you can find the value for this, we have always a table like this. So these tables, in the final exam, I'm going to provide you with this table. So that's why I'm emphasizing on that it is easy for you if you can learn how to write the notation, because you do not need to memorize all the formulas. But this table is actually very important. You have to know what is actually the right number or the right column for you to choose. That's why we write the notation, because, for example, the notation here, I told you that the notation works exactly like a GPS. It's going to give you the direction, which value is the right value for you to pick. Okay, now I'll go back to the table. So this is the table that we have. The first and important thing that you want to make sure that you are in the right table, you want to be looking at the percentage that we have on the top right and left. So you want to make sure that you are on the right table. This is actually a very huge booklet that is actually the percentages usually start from even 0 point something until we have all the percentage 1, 2, 3, 4, 5. For every single percentage, we have a table. So the table is going to be provided to you in case you want to use it if you don't want to use the formula. So the most important thing first, you want to make sure that you are on the right percentage. The question gave us that the interest rate is 12%. So the first thing, you want to go and find the table which is for 12%. That's the first step. Secondly, we have 3 main columns here. The first one is for single payment. Second one is a uniform series payment. And then completely ignore the third column. So this is not something that you want to be looking at. So what we are going to be looking is the first 2 columns and then these 4 columns. We have single payment and we have uniform series payment. Single payment is for P and F, and uniform series is for A, the one that I told you earlier today, earlier in this. So single payment, it means that you are saving money today, or you have, for example, got a loan today and you are going to make one-time payment in the future. So it's all about one-time payment, or for example, one-time payment at the moment. So it's only one time. You're not going to be paying off multiple times in the whole duration. No matter how long is the duration, even if the duration 1 year or the duration is 5 years or 10 years, there's only going to be one-time payment. So if we are talking about one-time payment, it's included in the single payment. So you're going to be using the first column or the second column. For now, we only focus on these two columns. Okay, so I go back to the question. So the question asks us, suppose that 1,000 is to be received in 5 years' time at annual interest rate of 12%. What is the present worth of this amount? So the information that is given to us is that we have 12%, so we are on the right table. The second information is that the duration is 5 years. The first column that you see on the left here, N, this is the duration, so the year. So now the first thing that this means that this is 1 year, 2 year, 3 year, 4 year, 5 year. So the first thing that you want to be looking at the 5th year. So far we have found the correct row. So either we are going to be picking this value or we are going to be picking this value. If you look here, we have F/P, which is for the compound amount, and then we have P/F, which is for the present worth. So in the first one, we are looking for the present value, and here, here we are looking for the future value and we are looking for the present value. So if I go back to the same question, so the question, you have the present value and you want to know how much is it worth in the future. And you have already learned, hopefully, so far you know that how you have to be writing the notation. So we have here P/F, because P, the first one, is the one that is missing, and the first and the second value, which is F, is the one okay, sorry, I'm in the wrong question. That's why suddenly I surprised, why is it wrong? Okay, this is the same question. So the first value is the one that you are looking for, and the second value is the one that is being given to you. So in this question, you know the present value is 2,000, but you want to know how much is it going to be after 8 years with the 10% interest. So we are looking for F/P. So we go back to the table. This is, so far I was showing you the table for 12%. Okay, I'm confusing myself. This is the right question, and the question is 10%. So we go to the table, which is 10%. Every other thing is actually the same, only the percentage. Okay, so we are on the right table, is 10%. We come to the 5th year, and what we want to be looking at is the value for F/P. So we are looking at the first value here. For the 5th year, F/P, because we want to know how much is the future value of a present sum that is given to us. And that present sum is 2,000. So you come down here, you see that this value 1.6105, this is the value that we are looking for. So simply, you just copy this number and you... Okay, why am I saying 5 years? Is actually 8 years. That's why I said why is a different number. We have to look at the year 8, not year 5. Okay, so the year 8, the value is 2.1436. So simply you just copy this number and you place it instead of the notation times the 2,000 which was given to you, and still you are going to get the same answer. So either you are using the formula or you are using the notation. At the end of the day, you will get exactly the same answer. Okay. because now this is the first time I'm trying to explain everything to you, it might seem that it's maybe like kind of confusing for the first time, but to me, I always prefer to use the notation rather than using the formulas, because memorizing all the formulas is actually not going to be easy. Because imagine right now there are 2 formulas and 4 more formulas is actually going to be added. So in total, only for this part, we have 6 different formulas. So it might be a bit difficult to memorize exactly the formulas. Okay, so another example. This should be much easier. Suppose that 1,000 is to be received in 5 years. So we have 1,000 to be received in 5 years. At an annual interest rate of 12%, what is the present worth of this amount? So you have your I equal 12%, you have N equal 5 years, and then you have F, which is equal 1,000. So you have this time around, you have the future. What is missing is the present. So if we want to use the formula, so you can just write down the formula, you can place your number. So this is the 1,000 principal for the future. We have the 12% interest, 5 years, you can get the value. So if this is, you are using the formula, but remember that this formula is not going to be given to you, of course. If you are writing the notation, so in this question, you know that the present is something that you're looking for. So P equal F, the future value was given to you. So if present value, P slash F, present value of a future sum that you already know at I interest N years. So P slash F, the interest was 12%, the duration was 5 years, and the first principal was 1,000 that we have. So we have this. We need to go to the table of 12%, look for the year 5, and look for the P slash F to get the value. So I will go to the table of 12%. I will come to the, yes, okay. I'll go to the table of 12%. I'll come to the year 5, and I will be looking at the value here. So I just need to take the value and copy it here. So 1,000 times 0.5674, and in total you can get the 567, and the value is exactly going to be the same as above. So either you are using the notation or you are using the formula, you're exactly going to get the same answer. Okay, do you have any questions so far? Because these are done for the single payment, and then after this I want to start with the uniform series. But I want to make sure that you have already understood this and you know how to use the table. If you have any question, please write down for me. Here, I can read your comments because sometimes the voice is not very clear. If you have any question, write it down for me now so that I can answer and I can proceed, because I want to make sure that you have understood everything clearly. Clear? Okay, good. Okay, so the next one that we have uniform payment. The concept is still pretty much same. The only thing that is different is that this time around, instead of one single payment, uniform series is involved multiple payment. So the series of uniform payment that will recover an initial investment. So uniform payment is, the initial for the uniform payment is going to be A. Writing the notation, it is exactly similar concept or actually more or less I can say the same concept as what I have already explained to you until now. The only difference is that so far we had only P and F, and now I have added additional A to it. So we have a present value and a future value for single payment, and at the same time we have future value, present value for A, which is multiple payment, or we call it as a uniform series. Okay, in terms of cash flow, how we are going to be drawing the cash flow. Do you remember the other time in the class I already taught you how to draw cash flow, and I told you also it's very important for you to know how to draw a cash flow, because it's going to simplify the question for you so that you can understand what you have and what you're looking for. Secondly, in the final exam, we always do have a first part of chapter 4 question that starts with drawing a cash flow. Okay, so you are already familiar with this. You can understand that this is the principal or the present value. So here you have added something to your account because it's an arrow upward. It's like a plus. So for example, here you got a loan, you have received money. So basically, before this, in a single payment, we only have one time arrow down, is that mean that only one time payment at the end of the period. Where you can see multiple arrows here, it means that if we consider this year 1, year 2, year 3, year 4, if we consider these arrows, each one at the end of each year, it means that every single year you are paying you're paying an amount of money. The only thing in the uniform payment is that these payments are exactly going to be an equal amount of money, meaning that the first year, second year, third year, whatsoever year that you have, it's going to be exactly equal amount of money. Either the equal amount of money is going to be paid, which is like this, which means negative, or you can also be receiving equal amount of money. For example, if you are working, every single month you are receiving your salary, and your salary every single month is exactly the same amount of money. So if I want to draw a cash flow, for example, for my salary, for a salary, so every single month I need to draw a arrow upward here because it's exactly same amount of money and is going to be received at the end of every month. Okay. So, one thing that I forgot to explain here, the most important thing, so as I said, we can have a uniform series for both present value and for the future value as well. So the uniform series represented as A equal, so P is a present value, A/P means you're looking for the uniform series payment where you know how much you have right now. So the same concept, I is the interest, N is the year, how you write the notation, it is exactly the same. So if you have noticed so far, the only things are actually changing is these value. And these values, this one is always like this one, and this one is always like this one. So you have to know the only important thing in answering the question for chapter 4 or understanding the concept of time value of money, the main important or the first or the most important point is that you want to make sure to understand from the question what you have and what you are looking for. That's why I advise you that when a scenario is given to you, make sure that you are going to write down the question. I mean, when the question is given to you, do not copy the question. The first thing you want to do is to simplify the question for you. For example, a very long scenario is given to you. There are going to be lots of values in this question given to you. So simply, you can just simplify it for yourself. Whatever, if you saw a present value, directly write P equal that value. You saw a future value, write F equal the value. You have seen an interest, you have seen a duration. Just simplify it for yourself so you would know at the end of the day what is missing. So according to what is missing, you can simply write down the notation. So similarly with this, the only difference that this is for the F, for the future. The future value of an investment based on periodic constant payment and a constant interest rate. So we have F equal A, F slash A, the I, which is the interest, and the N, which is duration. So simply, if I want to put this into a cash flow diagram, every single, if I want to give you an example for this, this is simply, it means that if every single month for yourself, if every single month, for example, you can save 100 ringgit, how much money are you going to have after, let's say, 10 years? So you can simply put it into calculation. So every single month you are saving something, for example. So you want to know how much is the value of it in the future. But the important is that the amount that you're going to be saving is going to be basically a same amount of money. It's not going to be different from one month to another. Okay. So this is not a very good example. It's better to do a better example. But for example, what we have here, what represents is that here we have a duration, we have the years. Here, when you can see that, for example, from year 1 to year 5, there is 500. Means that every single year, 500 has been added or 500 has been received, for example, because it's a cash in and it is positive. And cash out means that at the end of the 5 years, you are going to be paying 2,763 if the interest is going to be 5%. Okay, let's do examples so that you can understand it clearly. Okay, what you can see here, it is exactly similar with a single payment. The only difference that this time around, it is for the uniform series. So basically, of course, we have four different situations here, because now we are dealing with present value, future value, and uniform series. So each one of these could be actually missing, and then you can definitely find it. And the uniform series could be based on future and present at the same time. So that's why we have four different formulas. So the first one, we have the series compound amount factor. So this is where you are looking for the future value when you know how much is actually how much is actually the uniform series. For example that I can give for the first one here is that how much the money is going to be in the future if every single month you are saving a certain amount of money, because A is something that you already know. The second one, we have capital recovery factor. So A means that A equal P, A slash P. So A slash P means that you want to find out how much you need, for example, how much you should have saved in before to have a certain amount of money like right now, or value of it, for example, for the present. For the third one is a series present worth factor. So we have P. So you want to calculate how much is the present value of uniform series with the interest and duration. And the last one is the sinking fund factor, which you want to know how much, for example, you need to be saving every single month. So you want to know A, the uniform series, to have a certain amount of money in the future. For example, if you are planning to buy something in the future, let's say for the mid 2024, you want to make sure that you have, for example, 5,000 ringgit cash. You need 5,000 ringgit cash in mid 2024. So you want to know how much you need to save every single month to make sure that you are going to have 5,000 ringgit, 5,000 ringgit in the mid of 2024. So the duration is clear. The only thing that, for example, you have to, of course, have an interest. So I'll just give you an example. Okay, so for each one of this, we will do one example, but the concept is exactly the same. And you can see, oh, the main thing actually I forgot to mention here, all I have shown you or all I have explained to you is actually writing down the notation. You can see that either you can, similar with the single payment, you can use the notation which is written below here, or you can use the formula which is given to you here. But to me, as long as the simple way is that as long as you can understand what is the question, what is the question ask you, okay, how much you need to, for example, what is given to you and what is the thing that you need to calculate, you can always write down the notation simply by yourself based on the information which is given to you. Where if you want to use the formula, there is no way except that you have to memorize the formula. And you can see here we have 4 different formula and we had 2 more in the single payment. So 2 formula for single payment and 4 formulas for the uniform series. So here are 6 formulas, and to me, I believe that it's not going to be very easy if you want to memorize all these formulas, and this is not something we would be given to you in the final exam, of course. So it's much easier that you can just write down the notation, and using the table you can just simply get the value. Okay, so the first example is how much will you have in 40 years? So directly you can see that you have been asked for the future. So how much will you have in 40 years if you save 3,000 each year and your account earn 8% interest each single year? So you have your interest at 8%. So I is 8%. You have your duration, which is 40 years. And then you have the principal, which is 3,000. But the principal is written if you save 3,000 each year. It did not mention that you save 3,000 one time. Saving 3,000 each year means that for 40 years, every single year, you're going to be saving 3,000. So it means that more than one time, right? It's not a one-time payment anymore. It's not a one-time saving anymore. It's more than one time. So definitely is going to lay on uniform series. So how to write the notation? So you know that F, the future is missing, equal. A is something that you have because you know that somebody just came and I got, okay. So you want to calculate the future value where you know that the uniform series is 3,000, the duration is 40 years, and the interest is 8%. So for the writing down the notation is F/A. Why? Because you want to know how much is the value in the future where the uniform series is given to you. The same concept. If you do not want to forget how to write this, because everything, actually the most important part in this, the most important thing is how to write this notation. I know that writing the percentage and year is quite very easy. It is very simple. To figure out the number here is also very easy. It's just something that you are copying from the questions. The most essential is how to write this part only. So for this is 100% based on your understanding. You want to make sure that you understand the question very well. The question clearly is telling you that you don't know how much is it going to be in the future if you save 3,000 each year. So because the 3,000 is each year is going to be something that is continuous. So is A. So means that you have A. And as long as you have A, here is solved, and what you are looking for is the future. So it's F/A. So all you need to do, you need to go and find the table of 8%. Do I have the table here? Okay, I don't have the table of 8%. But let's say, okay, let's say this is 8%. I know this is 5%, but just assume that this is a table of 8%. So in the end, all you need to do is to go to the year 40. Usually this table here is actually just until year 10, but this table is very long table. Is usually we have it up to 100 years. So a full table would be given to you. You don't need to be worried. So you need to go to the year, for example, 40. How to find the right column, as I told you, these last two, you want to ignore them, delete. This is not even something that you're going to be learning in this course. So only you're dealing with this 6 column. So the first two, it was only based on if there's a single payment, one-time payment in the beginning or one-time payment at the end only. These 4 column, which is under the uniform payment series, which is A, it basically means that there is more than one-time payment. So maybe every single year you are paying money, or every single year you are receiving money. So it could be year, it could be months. That's not a difference. Okay, so what you want to be looking at here, we have A/F. So means that you want to calculate the uniform series when you know how much is the future. The second one is A/P. You want to calculate the uniform series when you know what is the present sum or the present value. Next one, we have F/A. So it's that we have the future, and is here finding F when given A. You want to find how much is the future value of uniform series right now. And then we have P/A. So it's actually finding P when given A. You want to know what is the present value of uniform series. So these two are exactly just vice versa each other. So this is for the present, this is for the future. Okay, so let's do this. Let's do this example. Unfortunately, this is an online class, but if it was in the class, of course, I would force everybody to do these manually. But I hope at least for these people who are here, they can do it manually with me, because it is very simple, but a small mistake, can ruin the whole questions. So try to follow, and hopefully you can get it done. Okay, suppose you make an annual contribution of 3,000. So annual contribution of 3,000. Simply, it means that every single year you are paying 3,000. So it's no longer a single payment, it is uniform series. So already you know A equal 3,000. So let's see what is the rest of question. To your saving account at the end of each year for 10 years. So we have the duration N equal 10. If your saving account earns 7% interest annually, so means that I equals 7%, how much can be withdrawn at the end of 10 years? So you want to know how much you can have after 10 years. If each single year you are saving 3,000 for 10 years, and your account is actually earning 7% interest. So if you want to use the formula, basically you just place the number and you get the value. If you want to rewrite, if you want to use the notation, so you have to be able to write the notation. So how we write the notation? Clearly the question is asking how much is it going to be after 10 years. So F is something that is missing, because every single year you are paying 3,000 or you're saving 3,000 in your account, so you already have A. So is going to be F/A. So A is the 3,000. This is wrong. Okay, correct this. For those who are here and they can hear me, this is wrong. This is not P/F. This should be A/F. Sorry, this should be F/A. This is wrong. This is correct. This is wrong. Correct this one. I just noticed it right now. Okay, so we have 3,000 F/A at a 7% for duration of 10 years. So what you need to do, you need to go to the table of 7%. That's the first thing you want to be looking at. Secondly, you want to be looking at the year 10. So you come until you find the year 10. So it's very clear. And then your answer is within these 4 columns. So which one of these 4 columns you want to be looking at is the F/A. And you find the value is 13.816. So 3,000 times 13,000, 3,000 times 13.816. So it gives you the value of 41,000, which is exactly the same value if you use the formulas. This is an example, you can do it by yourself. Okay, another example that we have, this is from now on, I will do another, maybe 2 more example. They are a same concept, is just that what is going to be different, that which value is going to be given to you or which value is going to be, for example, asked from you. In the example just now we saw it together, is that A was given to you, how much you want to save every single year, and then you want to know how much is it going to be worth in the future. So you want to know the future. F was missing, where A, something that you already had. Okay, in this question, how much would, okay, is written wrongly. How much is needed today to provide an annual amount of 50,000 each year for 20 years at 9% interest each year? So I want you to read it one more time. How much is needed today? So you want to know how much is P. So means P is something that you do not have it. Okay, how much is needed today to provide an annual amount of 50,000? Once it comes something that annually or monthly, means that it's happening more than one time. So you already know that A is equal 50,000. The duration is 20 years. The interest is 9%. So simply, you can write the notation by yourself. The most important thing, again, is a P/A. P, you want to know what is the present sum of uniform series or A value that you have. So you want to know what is the present sum of 50,000 after 20 years, for the duration of 20 years and with the interest of 9%. So again, what you need to do, you need to go and find the table of 9%. Okay, good, we have. You need to go and find the table of 9%. You need to come down to the year 20 because it was questions. And then all you need to do is just look for the column of P/A, exactly the same thing that you have written by yourself. Okay, next one. How much would you need to set aside each year? So you are looking for A clearly. How much would you need to set aside each year? How much you need to put aside each single year? So it means that A is something that is missing. For 25 years, N equal 25, at 10% interest, I equal 10%, to have accumulated 1 million at the end of 25 years. So we are talking about future. The 1 million is going to be in the future. So the question is telling you, if you are going to have 1 million after 25 years, how much do you need to save every single year? So you have F, and what you are looking is for A, which is how much you need to save every single year. If you can just understand the question, then you would be able to write down the notation. And once you are done writing down the notation correctly, the rest of it is very simple. So the 1 million is a future value that is given to you. So we have A/F. You are looking for how much you need to save for a future value that you already know. The first one is what you are looking for. The second one is what is being given to you. Always is like that, remember. So all you need to do, you go to the table of, which we don't have, you need to go to the table of 10%, come down to the year 25, and then from the uniform series, you go and find the value which is under A/F, which is going to be this value, 0.012 times the 1 million. So it's going to be 10,200. So it means that if you save 10,200 for each year, every year you save 10,200 for 25 years. After 25 years, if your account is earning 10% interest, you will have 1 million. That's basically just the meaning. Okay. This is repetitive. Why is it repeat? Oh, we had the table. Okay, this is the one. The table of 10%, the year 25, and you want to, you are looking for A, you want to know how much is A, where you know already that F is 1 million. So this is the value times 1 million, it would give you the answer. Okay, so next one. If you had 500,000 today in an account earning 10% each year, how much could you withdraw each year for 25 years? So you can see, you can read it one more time slowly. If you had 500,000 today, so it's something talking about today, right now, present. So means that P equal 500,000. The earning account is 10%, I equal 10%. How much could you withdraw after 25 years? So 25 is going to be the duration, which is N. So what is missing is A is missing. And you can see how much could you withdraw each year. It is very important. Always be critical with the words that is being used, because I can say how much, for example, we can withdraw in the future. If it's one-time payment or one-time withdrawal, is very different than I'm going to be withdrawing every single year. You should understand already the concept of these two difference. So this is how much we can withdraw every single year. So we have the 500,000 A/P, because we want to know how much we can withdraw for the present value that we have, which is the 500,000. The 10% it was given to us. The duration was 25. So you'll go to the table of 10%, which we don't have it here. Okay, same one. You can go to the table of 10%, 25 year. Oh, sorry. You can go to the table of 10%. You can come, oh, this is the value. You can come to the table of 10%, and the year is 25, the year 25. And what we have here is actually A/P. So it's different than this one. So this is going to be the answer for this question, because this one is for the present. That is for the previous question. So this is the value. You can see that is 0.11017. Okay. Did I go back? Okay. Let's do this one. Let's do this one now. So this one is actually has this one also has the cash flow diagram, so you can make sure that. Why do I feel like no? I hope I didn't do this. Okay, Boeing Company has borrowed 250,000 to purchase an equipment for gen splicing. The loan carries an interest rate of 8% per year and is to be repaid in equal installment over the next 6 years. Compute the amount of this annual installment. So you can read it one more time carefully for yourself to see what we have and what is missing. Okay, so you can see Boeing company has borrowed 250,000 to purchase an equipment. So means that the 250,000 is whatever it is actually a present. So the present value is going to be 250,000. The loan carries that interest of 8%, so I equal 8%. And to be repaid in equal installment for 6 years. So the duration is 6 years, and the equal installment, that it means that every single year you are going to pay a same amount of money. So the first thing usually in this kind of questions you want to do is to draw the cash flow, because first of all you need to learn it, and secondly is actually going to simplify the question very well for you. So in the beginning, we have 250,000, which is a plus. So the arrow is going to be upward, because 250,000 is something that you have borrowed, means that it has been added to your account. And then for the duration of 6 years, year 0 to year 6, or you can place here year 1 to year 6, for each single year, you are going to pay equal amount of money, which you still don't know how much is it, if the interest is 8%. So what you are going to calculate, basically you very clearly, you want to know how much is A to calculate how much is equally need to be paid. So if we want to write the notation, it's definitely going to be A/P, because A is the one that is missing and you have the present value already. So as long as you know that, the rest of it is easy. So we have the present value is 250,000. A/P, so you want to know how much is that equal amount of money for each year, when the present value is something that you already know how much is 250,000. So 8%, you go to the table of 8% and you go to the year 6. So you can find this value and then you will get the results. So means that for 6 years, every single year you need to pay 54,075. That's what it means for the answer. But the same amount is going to be for the continuously for 6 years equally. This is the value. Okay, so there are more. This is also another example. There are more examples I have already covered in the note, because I believe that I've already explained how to do it. It is really simple, very, very simple. It's just that you have to make sure that you can understand the questions, because sometimes one of the major the major mistake that I have seen on student is that they cannot, or they make a mistake about what they have and what they don't have, because they sometimes some of the students, they will not be able to differentiate between, for example, present and the future. Maybe the value that is given to them is something related to the present value, but mistakenly they're going to be placing it as, for example, is going to be receiving the future value, or this is still okay. Common mistake is between a present value, for example, for the uniform series and single payment. This is something that if it is not clearly highlighted in the questions, many students, they make a mistake that either, for example, the payment is one-time payment only, because you can see if it's one-time payment, if you look at this table, if it's one-time payment, either you are receiving one-time money in the beginning, or you are paying one time at the end of the period. Either way, you are going to be using these two columns only. This is about one-time payment, single payment. But when there is going to be more than one time, even if it's just 2 times or 3 times or 100 times, doesn't really matter how many times, anything that is above 1, is going to be under the uniform series. And the important is that the amount is going to be a fixed amount for the whole duration. Okay, so this is the end of chapter 4. I am done with the chapter 4, and all is left is actually chapter 5, which is we will cover it for the next week, which it is actually, that one is quite also very simple. The most important thing, it was what we had in chapter 4. Chapter 4, yes, this chapter. Okay. Any question? Do you have any question? If you have any question, you can ask me. Okay. No question so far. If not, you can scan your attendance and it will be all for today. Okay. So you can scan your attendance. For those they have already attended, they have already scanned. And if you don't have any other question, thank you very much. Okay, for the next week, I will also conduct the next week class online. So because we only have chapter 5, I will, yes, we only have chapter 5. I'm done with chapter 4. So for next week, I will conduct the class also online. And after that, the following week, we are going to have a test, which is a combination for all chapters. So I want to complete everything for next week so that you can start studying and preparing for the quiz, as well as, of course, preparing for the final exam. Okay, so for those that have already scanned, thank you very much. Marvin, I will mark your attendance after this. Those that have already scanned, thank you very much, and have a good day.
Thank you, Doctor.
Thank you, Doctor.
Welcome.
Thank you, Doctor.
Welcome.